Hello, and welcome to the topic of sequences and series. The first thing that we need to talk about with this topic is introducing the idea of what a sequence is. A sequence is just a set of numbers that follow a particular pattern. Now, there's many different types of patterns, and the good thing for you is that there are only two particular types of sequences that we look at in the HSC course. That's the purpose of this video, to introduce those two types of sequences. The first of those is an arithmetic sequence. Now, this type of sequence is something that you've seen many times before, right? 1, 2, 3, 4, 5, 2, 4, 6, 8, 10. Any of those kinds of sequences. The formal definition of a sequence like this is one where our term with an n subscript minus the term before that is constant. So think in our example of 1, 2, 3, 4, 5, we have a changing term of 1, so a difference of 1. For a sequence where we go 0, 5, 10, 15, our difference is 5. So that distance has to be the same, the difference has to be the same for each of those sets of terms. And we call that difference d. And this naming convention is going to be really important later on when we start looking at operations with these sequences. One of the definitions that we can give here is our definition for the next term of a sequence. So the next term is going to be our previous term plus our difference. And this gives us a slightly more complex formula for the term, any term in an arithmetic progression, which will be the first term plus n minus 1 times the difference. Essentially, we're picking our starting term and we're applying that difference n minus 1 times to get to the point that we need to be. That's our arithmetic sequences, and we're about to look at heaps of operations that we can do with those in the rest of this chapter. The next part of this, the next type of sequence, is a geometric sequence, which is a very similar idea, except instead of the difference being the same between each of them, we have a common ratio. Now, what this means is that if we take any term and we divide it by the term we had before that, that's going to be constant for each of these. So, for example, instead of going 2, 4, 6, 8, 10, I could go 2, 4, 8, 16, 32, and so on. And so in that case, instead of my common difference being 2, my common ratio will be 2. Essentially, the terms are doubling each time. And we call this ratio R. And again, remembering all of these letters will be really important with the later formulas we'll look at. A simple formula we can give to this is that any term will be the term before it multiplied by the ratio. And then the general formula for these, so what we call the formula for the nth term with this subscript n, is the first term times r to the power of n minus 1. Essentially, we're taking our first term and applying the rate n minus 1 times to get to that next term, to get to that term that we want of a geometric sequence. That's a summary of these two types of sequences. We're about to look at some problems with these sequences next.